Oh, it says.
Morning Year 10. This is what we're going to be looking at today, surface area of a cone. This is a new topic for most of you and it is a little bit complicated. So I'm changing the way the presentation's put over this morning. Surface area of what a cone is what we're going to be dealing with. Very quick starter. So copy down those two examples. Factorising this expression here, it's a quadratic expression, so factorising that, and then solving an equation there. If you can't do them, that's absolutely fine. I'll be going through them in a minute. So if you want to pause the video, having copied down those two examples, when you start up again, I'll be going through the solutions for you. Okay, the solutions. First one we're going to look at, factorising this quadratic expression. It's a quadratic expression, so it means you're going to be factorising the expression into two brackets. The first thing you can do is you can put an x at the front of each of the brackets. Then you've got to decide what two numbers multiply to make a negative 15 but add to make a positive 2. So because they multiply to make a negative 15, it means that one of the numbers has got to be a negative number and one of the numbers has got to be a positive number. The result when you add them together is a positive. So the greater in magnitude is going to be the positive number. And the two numbers that we need to look at are a positive 5 and a negative 3. That is now that expression factorised into two brackets. Solving this equation. We've got x's on both sides, we've got numbers on both sides. So we want to get the x's all onto one side and the numbers all onto the other side. So let's just consider getting the x's all onto the left hand side. So subtract 5x from each side. So each side we're taking away 5x. On the left hand side that means we've got 4x minus 13 equals 11. Now we want to get the numbers onto the right hand side. So we add 13 to both sides. So that now means we've got 4x on the left hand side and we've got 24 on the right hand side. Divide both sides by 4 gives us a value of x equals 6. And that is your starter completed. Now, quick bit of a revision for most of you. Here we've got a cuboid. If I asked you to find the surface area of that cuboid, what have we got to do? We've got to find the surface area of each of the sides and add them up. Now cuboid has got 6 sides. Okay, it's got 6 faces, 6 sides. So let's just put some numbers in here. That's 2 centimetres, 3 centimetres and 5 centimetres the length. What have we got? We've got a 2 times 3 to give us the surface area of that rectangle at the end. That's also going to be the surface area of the rectangle at the other end. So we've got 2 times 3 to give us that surface area, and then we've got 2 lots of it. 2 times 3 is 6, 6 times 2 is 12 centimetres squared for the two ends, the two smaller rectangles. We did the 2 sides, so these long sides here, it's 5 centimetres by 2 centimetres, so it's 5 times 2. But again, we've got 2 of them. 5 times 2 is 10. 2 times 10 is 20 centimetres squared. And then finally, we've got the roof and we've got the floor. We've got the top and we've got the bottom. So each of those is 3 centimetres by 5 centimetres. And again, we've got 2 of them. 3 times 5 is 15. 2 lots of 15 is 30 centimetres squared. So that's all 6 faces, all 6 sides have been accounted for now. So to get the total surface area of that cuboid, we just add all of those together, which gives us a grand total 12 plus 20 plus 30, 62 centimetres squared. That should have been a revision, and it should be fairly straightforward for you. Very similar example, if you had a triangular prism, what we've got to do to find the surface area of that triangular prism, we've got to find the area of the triangle at the end here. We've then got the same surface area for the triangle at the other end. And we've then got a floor, we've then got a back, and we've then got a sloping surface there. So as long as we've given enough dimensions, enough information to be able to work out those rectangles, the rectangular areas there and the triangular areas at the end, we can just add all those together and we can get the total surface area for that shape, that triangular prism. But what we're looking at today is the surface area of a cone, and that is a little bit more complicated. I'm going to jump on a little bit here and I'm going to get you to write this down. Make a note of this. The surface area of a cone is pi r squared plus pi rl. Now that's the formula that we're going to be working towards proving why that's the case. Surface area of a cone. The cone. Now we've been dealing with the volume of a cone, okay? But the surface area, we've got a base, which is a circle. But then we've got this surface area for the main length. How do we make a cone? We have a shape like this, which you'll recognise. Oh, didn't need to do that, did I? You'll recognise as a sector of a circle. A cone is formed by taking the sector of a circle and joining the straight edges, and that forms a cone. Now, I've given you a formula there which I've told you to take note of. Let's explain that a little bit more. We've got a cone. So it's got that circular base and it's got a slanting surface all the way around. R, it's a radius. You should be used to that term. So that is your radius. Okay, for the base, that circular base, that is that R term in that formula. So it's very important that you understand what that R represents. It represents the radius of that circular base to the cone. Pi is a term you understand. You understand pi. L is this sloping length. Now when we were dealing with the volume of a cone, you remember the volume of a cone was pi r squared times the vertical height. This time we're not interested in the vertical height. It's not the vertical height that we're looking at. We're looking at this sloping height, this sloping length. Okay, and we're calling it L. And that's how it relates into that formula. R, you should be used to, is the radius of the circular base. But L is this slanting height, the length of that slanting height. So that's the formula that we're aiming to prove, and that's the formula that you'll be using in examples. But I am going to go back and I'll just show you how that formula is achieved. If ultimately you don't understand how this formula is achieved, that's not a massive problem. But it is useful for you to be able to appreciate where that formula has come from. So, I've got a cone. The radius of the base is R. The sloping length, the sloping height is L. So if I break that down, I've got that circular base, which has a radius of r. And don't forget, I'm trying to find the surface area of the whole of that shape. So the circular base, it has a radius of r. So straight away we know what the surface area of that base is. We know that's going to be pi r squared. Because we've done that, that's knowledge that you should have in your head. But what I told you was that that cone has been created by taking the sector of a circle and bringing the straight edges together to form a cone. So I've drawn you a circle here, and what happens is that length L, where those straight edges have been brought together, that length L is that sloping height, and it's these parts of the sector. Okay? So this is my sector in here. This is my sector that I'm interested in. And that's what we've got to find the surface area of. Now, if we look at the area of that sector, what's it related to? The area of that sector is going to depend on the length of this arc. So the longer this arc is, here, this arc, the longer that arc is for the sector, the greater the area of the whole sector is going to be. If we had a small arc, it's going to be a small area. If we have a big arc, nearly the whole circle, it would be a large area. Okay, so they're related. The area of the sector is related to the length of the arc. Similarly, the area of the big circle, the whole circle, is related to what the circumference is of that big circle. Okay, the area of that big circle is related to the circumference of the whole circle. Also, don't forget that the length of that arc is also related, depends on the circumference of the circle as well. So the length of that arc is just part of that circumference. So the area of the sector is related to the length of that arc, and the area of the big circle, the whole circle, if we were considering that, is related to the circumference of that big circle. So what I've done is, because they are related to each other, I've formed an equation there. The area of the sector is in proportion to the length of the arc. The area of the big circle is in proportion to the circumference of that big circle. So I've made them equal. Okay? Because they're proportionate to each other. Now, what's the area of the big circle? What's the area of that big circle? Pi r squared is the formula for the area of a circle. But here, I'm using L. L represents the radius, if you like. So the area of that big circle is pi L squared. Okay? The area of that whole circle, pi times the radius squared, is pi L squared. Now the length of the circumference of that big circle, so 2 pi r is your formula, 2 times pi times the radius is 2 pi L. Okay? So that's circumference of the big circle is 2 pi L. But don't forget that the length of that arc is the distance around the circle at the base. There's the length of the arc, all the way around there, and that is the distance around the circular base of the cone. So that is going to be 2 pi r. The distance from here round the arc to here is going to be the same as the distance around there, so it's 2 pi r. So that means that we've got a nice little equation now. We're trying to find the area of the sector, that's what we're trying to find, but we've managed to replace all the other elements of this equation with bits and pieces of information that we know. What can we do with that? We can cancel things down. There's a 2 pi there that we can cancel out with the 2 pi there. We multiply both sides by pi L squared. That means that that can cancel out with that. This side is multiplied by pi L squared. So we can do some more cancelling. The L on the bottom can be cancelled with one of the L's on the top. So now what are we left with? We're left with just the area of the circle, or area of the sector on the left hand side, is equal to, we've got an R left, we've got a pi left, and we've got an L left. So pi R L. So the area of the sector is equal to pi R L. So that means that the surface area of the whole cone is the surface area of the base, pi R squared, plus the surface area of that sector, the area of that sector, which we've just gone through and proved is pi R L. So the upshot of all of that is, that proof is that the surface area of the cone is equal to pi R squared plus pi R L, where R is the radius of the base, the circular base, and L is the slant height. And that is the formula that you're going to have to actually apply when you're doing your examples. Now, please don't worry if that proof is a little bit complicated. It is a complicated proof. That is the easiest method of explaining it that I've seen. I've gone through that method for you. You can stop and start the video and try and understand what I've been talking to you about and how I've achieved that proof. But ultimately, what I do want you to be able to do is I want you to be able to look at that formula, look at examples of cones, and be able to use that formula to find the surface area of a cone. That's what you need to be able to do. So, thank you very much for your attention. Next time. Okay, Year 10, surface area of a cone. You've had a presentation about where that formula comes from. Now, one practical example of how you'd actually apply that to a question. So the surface area of the cone, which you should have made a note of, is pi R squared plus pi R L, where we have a cone L is that sloping length there, and R is the radius of the circle that is at the base of the cone. So those are the two identities that you need to know, the lengths that you need to know, the length, that sloping length, and the radius of the circle at the bottom. So how does that actually work out when we're trying to do an example? So here we've got a cone. We're being asked to find the total surface area, and don't forget, if you're asked to find the total surface area, it is the surface area around the outside here, like you get for an ice cream cone, but it's also the circle at the base of the cone as well. So, the area of the surface is going to be pi R squared plus pi R L. I'm going to take the value of pi being 3 ultimately, but let's just not put pi into it for the time being. So R squared, R is this radius, the radius of the circle at the base. So it's pi 4 squared plus pi multiplied by 4, value of R, and multiplied by L, which has got a value of 10 in this case. So if we multiply that all out, we've got 16 pi plus 40 pi, which is equal to 56 pi altogether. And if we took a value of pi of 3, just say pi equals 3, just to make the calculation simple, it gives us an area of the surface there would be 56 times 3, which is 168 centimetres squared, roughly, because it's going to be a rough figure there because we're taking the value of pi of equal to 3. And that's all you've got to do to solve these problems. It's just about slotting in these values. What is the radius? What is that slanting length? Slot them into your original formula, and that is all there is to these questions. Don't forget that if they gave you the total surface area and they gave you, for example, the radius, they could ask you to find the sloping length, and you've just got to rearrange that formula to give yourself an opportunity to calculate the sloping length. So it's just about manipulating the formula around. But that's a basic, straightforward example. So hopefully that's been useful to you. Thank you very much.